What have I done so far? Okay, but can anyone explain to me how I multiplied? Because a few people might be confused with how I multiplied. So first of all, why are there little rainbows? What's the snazzy math term for what I did? Distribute. Distribute. This is a problem. It's been given to me. I'm distributing. Which I guess in some ways, Andrew, you might think of the motion of plugging in and the motion of distributing. But plugging in, remember, is substituting, taking something out, putting something in. Distributing is multiplication. Okay? So I'm multiplying, I'm distributing. Now, when I multiply, why did the 8 stay the same? Yeah, if you look at the root 3, you guys could draw a little understood 1 there if that helps. You could draw a little understood 1 there. The 8 gets multiplied by the 1 because they're both where? Where's their position?
Inside.
Well, the 8's not inside.
I mean,
yeah, outside. So you multiply the outsides and you multiply the insides. So 8 times 1 is 8, but then you can multiply the insides. What's 2 times 3? 6. And 7 times 1 is 7, and 32 times 3. Maybe that's not something you could do off the top of your head, but we could always go to the side, or if you were allowed to use your calculator, 3 times 2 is 6, 3 times 3 is 9. No big deal. Might have been faster than you even finding the calculator. Square root of 96. Now, here's my question. Can you guys look at the other examples we did yesterday? Example number 1 or problems 1 and 2. Are we allowed to put these two together right now as they are? Are we allowed to combine them? No. Why not? They're not like terms. You can only combine like terms. So the question is, what do you guys think? Do you think we should just box it and be done? No. The one thing that we need to think about before we end a problem is actually where we started, chapter 9, section 1. Did anybody find their 9.1a homework yet? Yes. Can you look at it real fast? Can you look at numbers 5 through 9? Because numbers 5 through 9, you shouldn't have shown a lot of work. Does anybody see what kinds of answers they were giving in 5 through 9?
Yes.
Yeah, yes or no. They were yes or no questions. Hold on, wait a minute. What was at the beginning of 9.1, which might be at the beginning of the quiz tomorrow? Simplest form. Are either of these in simplest form? Do you remember what it takes to be in simplest form? Dan, you're saying no. Which one's no? Which one? Yeah, the 796 is not in simplest form. So the problem is, like, out and beyond where we are right now, zoomed into, like, technically, the 9.1c homework, which is up there on the board, 75 to 79, 83 to 86. Where we are in the section is at the very end of the section. We have to remember where we were in the very beginning to know how to go or where to go. You just have that relation to focus. So then square root of 96, basically, he can be broken down. And since he can be broken down, he's not in simplest form. If he's not in simplest form, I can't stop the problem. So in all of section 9.1, if something's not in simplest form, we can't stop. Now, let's remind, because we have our perfect squares, our perfect cubes up there, which I want to leave up there, because to some of us, they're not as natural as to others. Over here on this sideboard, since we have a quiz tomorrow, and you guys have out your 9.1a worksheet for me to grade, right? Or at least for us to go over, for us to study. Can you remind me of what it takes to be in simplest form? If we can't stop a problem with a radical, unless it's in simplest form, let's review what radical simplest form looks like. What's the first thing that needs to be true for a radical to be in simplest form? What was wrong with the 96? Yeah. We have to check and see that what's underneath the radical can't be broken down. So can't be broken down. And I like, Jonathan, how you were putting it. No factors with perfect. I'm going to put squares or cubes because it depends on whether you have a squared root or a cubed root. But Jonathan, actually, you were saying something to do with n, and that's really good because there could be fourth roots and fifth roots and sixth roots. We're just not seeing them. There could be bigger powers that are necessary, just we're only seeing squared roots or cubed roots. That's the first thing that has to be true. Does anyone remember the second thing that has to be true? Yeah, Jonathan?
Can't be any fraction.
Good. There can be no fractions under the square root. Can I just go ahead and write it like this? I'll do like an A over a B. There can't be any fractions under the square root. If there were fractions under the square root, we could use that really snazzy property of square rooting the top, square rooting the bottom, and then trying to simplify. Trying to simplify. Maybe that's enough. Maybe this will be a perfect square, and we can go ahead and get rid of the radical. Maybe it's not. If it's not, well, hold on. Let's talk about number 3, because that leads into the if it's not. What's number 3 say? No radicals where? Good. No radicals in the denominator. And if there were radicals in the denominator like this one, or we could have another one, how we have something over maybe like square root of. If we have a radical in the denominator and we can't get rid of it, that's when we would do that. Ooh, hey, 9.1b worksheet. What's that snazzy term called for simplifying radicals out of denominators using this special multiplying by 1 creatively? What's that term? 9.1b worksheet. You can flip to it. You guys are supposed to have all 3 worksheets out. What's that special term in the 9.1b? Yeah, if you wrote notes on your worksheet, it's rationalize. If you wrote notes in your notebook, you should see it in your notes. Rationalize. So if there are any square roots in the denominator, we have to rationalize. So for this one, we try to break down. For this one, we try to split up. So if there's a problem, we try to break down, we try to split up, and then we try to what is called rationalize. And that means multiply by this square root over square root. The only time that gets funny is when we have to do a conjugate because there's a plus or minus. Like numbers 11 and 12 yesterday that we worked on together. So that was a big review kind of all of 9.1. We've been working on breaking down radicals and simplifying them. We've been working on splitting up radicals and simplifying them. We've been working on what if it's still stuck and rationalizing them. And this last worksheet is how do we do operations. So the first thing is, okay, learning how to multiply the outside times the outside, the inside times the inside. But then we have to say if it's not in simplest form, we have to simplify. So breaking down, has anybody even thought about 96 and what might go into 96? 16 goes in, Levi? How many times?
6.
Oh, 6 goes in. How many times does 6 go in? Or does, oh, okay, so 6 and 16? Cool. I think I would have divided by 2, but 6 and 16 works. Andrew, what's that? Can you wait until we finish these 2 examples and then I want you to finish the okay. So we have 6 and 16. Now, guys, technically, remember, we're splitting up the square root of 96 to be the square root of his factors. Now, we could technically keep going. For some of you, that might be helpful to look at and see, hey, isn't that 6 a 2 and a 3? And then isn't that 16 a 4 and a 4? Remember our talk from yesterday, if I see you making unwise choices in class, especially with a quiz tomorrow, and that includes being distracted or falling asleep or on your phone, I'm going to call you out on it just because I care. I care about you and your grade and your understanding, okay? Just a quick reminder. Now question, can I break down 2 anymore?
No.
Can I break down 3 anymore?
No.
Can I break down 4 and 4 anymore?
Yes.
Yes. Now some of you have memorized the square root of 16 is 4, so maybe you would have stopped and said, you're a 4 on the outside. Others of you would have been like, nope, I'm going to keep breaking down, and maybe you have memorized the square root of 4 is 2, and you're like, you're a 2 and you're 2. But others of you might just be in the habit of breaking down as much as you can, and why am I going to break down and group together these 2 different 2 times 2? What are square roots looking for? What powers are square roots looking for? 2. They're looking for the power of 2. So check it, just in case you haven't totally understood what we've been doing as far as simplifying radicals. when I take the square root of 16 and make it 4, it's because 16 can be rewritten as 4 squared. Or when I take the square root of 4 and say that it's 2, it's because 4 can be rewritten as 2 squared. Whenever you can write a number, a base is what we call it, to a power, and that power matches the root, like Jonathan was saying, it's the n power, the nth root, we're allowed to get rid of that radical and simplify it, and so it goes away. Some of you might have been a little confused as to why some numbers are going free and some numbers are staying stuck. But if you notice, do I have a squared of this 2? No. A squared of this 3? No. So both of those are stuck. Both of those are going to remain under the radical, whereas this square and this square was able to go free. But once again, we could have actually rewritten this guy, if it helps, as 4 squared. We could have let him go free earlier, but it's okay. Whether you let him go free up here, because you see that 16 is 4 squared, or whether you keep breaking him down and find a 2 squared and a 2 squared, you're going to end up with the exact same answer for that square root of 96. You're going to be able to see that a 2 times 2 was able to go in front, and a 2 times 3 got stuck underneath. Now check that in context of the problem. Check that in context of the problem. In context of the problem, we're trying to simplify down this big old 8 root 6 plus 7 root 96, and technically all of this work was just to break down this square root of 96. So we just figured out the square root of 96 is 4 root 6, because these 2's went free because they were both squares, and these guys stayed stuck because they, in a sense, haven't paid their sentence yet or haven't paid their fine. They're not able to be free yet, because they're just to the first power. But hold on, what else was there in this problem? Wasn't there an 8 root 6 plus, and who was in front of the root 7? Sorry, root 96. There was a 7. So we've replaced this root 96 with what he actually was, which was this 4 root 6. And then I just rewrite the rest of the problem. And now I can go ahead, and PEMDAS would tell me, what am I supposed to do next? Multiply, so I get 28 root 6. And what happens when we add those two together? Good. Like terms means 8 of these root 6's plus 28 of these root 6's is 36. Are you going to write with the rest of it correctly? 36 root what? Yeah. It's like terms. If I had 8x plus 28x, it'd be 36x. If I have 8 root 6 plus 28 root 6, I have 36 root 6's. It stays the same. If your brain wanted to make it root 12 or wanted to make it root anything else, you better write a note to yourself and say, don't, when adding or subtracting, don't change the radical. It stays the same. You're just combining like terms. But some of you are looking at this big old mess and you're like, didn't she say there was an easier way? Now, the easier way isn't to breaking down, because if you ever do get a big number, you just got to break them down and look for perfect squares. And look, if you know your perfect squares, you could have stopped way earlier. You could have seen the square root of 16 and been like, haha, he's 4. 4 root 6 and jumped down here. I'm just showing how radicals work in case your brain wouldn't have seen that square root of 16 is 4. Then you could have broken it down and said, hey, look, it's 4 squared. And maybe you would have gotten the 4. Or you could have kept going and gotten 2 times 2. Either way. But here's a question. I said that one way was to do the distribution first, because that's what a lot of your brains would do. And then, Danny, you were like, it's not in simplest form. We can break down the 96. My question is, and if I were you, I would put a big old or on your paper, and maybe even flip to the back of your paper. There is another way to do this problem. And the other way is, instead of looking at the multiplication, instead of multiplying and then asking, is it in simplest form? You could have also asked yourself the question, is it in simplest form to begin with? So Danny, I'm coming back to you. Could something have been, or do any of these radicals look like something that could be broken down? What do you think? Not the, well, the 3 is just 1 and 3. There's no squareds in there. The 2 is just 1 and 2. Remember, just looking underneath. No squareds in there, but can he get broken down? anything go into 32? He's not a nice one, right? 32 is not a perfect one. I can't do that. Bummer. But is he a number that can get broken down? Yeah. Does anybody know anything that goes into 32? 2 goes in. Yeah. So we could, if you have your calculator, you could divide by 2. And if you divide it by 2, do you guys know what the other number would be? 16. Close. 16. Now, remember how I said some of you guys recognize square root of 16 to be 4? Wouldn't that be a quick, like, wait a minute, I don't have to do all, it's not as big as 96, it's a lot shorter. So you could have divided by 2 because it was even and got 16. Now remember, you still have that 7 in front, and you still have, maybe some of you, it's best if you keep writing all of this, because then you don't forget it, because some of you, you might have totally forgotten that there was other stuff going on. But question, do we know the square root of 16? Yes. And if you don't, could you have gotten a 4 and a 4 and been like, hey, it's a pair of 4s, it's 4 squared. And then you could have said like, oh, that's right. If it's squared, the base is squared, he goes free. So then, one way or another, whether you know right here it's 4 root 2, or whether you know down here it's 4 root 2, I can rewrite square root of 32 to be 7 times 4, because he goes free. Anyone who's free, we write in the front. Anyone who's trapped, we write over here to the side. We could have gone ahead and actually simplified, gotten into simplest form before distributing. I know we still need to distribute, but we're actually kind of doing PEMDAS. We're kind of doing the parenthesis work first. So we can split down the 32, which is a lot smaller than the 96. We can simplify him, and then we can do PEMDAS, which is 28. Radical 2, 8 radical 2. Some of you are maybe recognizing that 28 and 8 because we had it a second ago. That does become 36. And I know we're not done yet, but guys, don't we just have to do one more multiplication? What's in front of this radical 3? What's the understood number? 1. So what's going to be the number outside the square root when I multiply? 36. And what's going to be the number under or inside the square root when I multiply? Okay. So, 2 options. One option is you can distribute first. And if you distribute first, you might just get bigger numbers, and bigger numbers might take longer to break down. Or you could look on the inside and say, wait, does anybody need to get broken down first? One way is simplifying your final answer. One way is simplifying the problem and then finding your final answer. Both ways are valid. Both ways are good. Just maybe one way is harder than the other. Which one makes more sense in your mind? Distributing first, and then breaking down maybe bigger numbers, or breaking down first? Okay, it depends. Some of you are like, no, my brain would distribute. Okay, so that's fine. You can get there. You're like, my brain would distribute. Cool. Your brain will get there, or your brain can get there if you just study that side. But if you're like, no, I want to make it as easy as possible first, well, then maybe breaking down and then distributing, or then I should say multiplying. There's no plus or minus, so I didn't even need to distribute because the plus was able to combine, and so I had one multiplication at the end. Now guys, hold on. You still have an example that we haven't done yet, right? So here's what I want you guys to do. I want you to all be on worksheet 9.1c. I want you to turn to your little groups of 4. We have a group 1, group 2, group 3, group... Oh, you guys only have 2 people today. And then group, and then Max and Andrew. Andrew, you can go to the bathroom now. I want you guys to go ahead and work together on number 3. Some of you have already done it. Some of you maybe haven't even looked at it. It's a lot like this one because, hold on, what do you guys see in number 3? I see distribution. So you have to choose as a group before you start. What do you want to do? Do you want to try to break down first? Look at that, 72. Or would you rather distribute and then break down? Choose which one because both of them are good. I'm going to show both solutions up here in just a couple minutes. But can you guys try to go ahead and get me the answer of this expression, either breaking down first and then multiplying, or distributing first and then breaking down? I'm going to put both of these up on the board so you guys can kind of compare and contrast to the example you're trying to do. Ready, set, example 3, go. I'm going to walk around the room, and if anybody has a question, they can ask me. But in your group, hold on. Are you guys talking? You have to choose a way. What do you want to do? Break down 72 or multiply first? What do you guys want to do? Break down 72? All right. Ooh, I think that was good. So breaking down 72. For those of you that haven't, very light. What goes into 72?
Oh, right here.
Now remember, when you break down 36 and 2, there's still little radicals, little square roots, right? And then, Jerry and Armando both took 36 and realized that 36 is 6 times 6. You can, but check it. Isn't the 6 a square? Square roots just mean squares. So as soon as you have a square, you can actually cancel it out. I'm going to pull up my screen really quick. Remember, guys, we love it when we get squares. Because if we can get a squared under a square root, we can always get rid of the square root. Andrew, Sean, Jeremy, and Levi, you should all be working on the problem together. Extra stories may not be super helpful. Have you guys worked it all the way out to the final answer? Yeah. Okay. 'Just in case this helps, I'm showing you y square root of 1 is 1, y square root of 2 is 2, y square root of 9 is, sorry, y square root of 4 is 2, y square root of 9 is 2. If I can get a square, I can cancel out the square root. Six times 6? Yeah. Were you trying to break down the 36? Or sorry, the 72? Is that what you were doing? Oh, you multiplied first. You could multiply first. I can do that one the first time. I think most people would try to break down, but what would end up happening if you multiplied first? 216. Okay. And then what did this next one become? Because that has a 1 in front. 3 root 6. But then we realize we have to break this guy down because he's way too big, right? And we can try to break him down, but 2 and 3, do we have any perfect squares? Any pairs? No, so we can leave him. Like he's in simplest form, he's done. But this guy, okay, so what happens when we divide 216? What did you divide him by? Who has a calculator? Because remember, you don't have to do all this in your head. It's a big number. You could divide by 6. Here. You don't have to use them. So I'm going to divide by 6. I can do it in my head to help you guys out. But you would do that in your calculator, right? Divide by 6 and you would get 36. Now hold on. Do our brains know, hey, I know that that's 6. If not, you could keep going and you could break them down more, right? Okay. So then we could break that down. Now, that is still 6 to the 1. That doesn't work. But what can I do with this? How can I rewrite 6 times 6? 6 to the power of. And what happens whenever I have a square root with a square? It cancels. So I can get rid of that guy. he goes free. But this one is
I kind of get it.
now, whenever anyone is free, we always write them in the front because they've been freed of the radicals. So our final answer for the 216 would be 6 root 6, and I still have this guy that I have to keep. Does that make sense? 216 we divided by, and you could have divided by 2 or by 3 or by, you guys just thought 6 went in and you were right. Some people look at this and they kind of have it memorized and they say 6. That's why some people just answer it quick. But for others, it's okay, break it down and see that it's 6 squared, which lets the radical be canceled out. It lets them go free. I don't need to divide it, I just need to subtract if they're like terms. Are they like terms now? Yeah, since they're like terms, their final answer would be 6 minus 3. 6 of these root 6's minus 3 of these root 6's is 3 of these. Oh, because that's just me breaking down. I guess I could have technically kept writing this the whole time. I just didn't. I was being kind of lazy. So I was breaking this guy down, and this guy just kind of was hanging out. And what's happening is as soon as I see a pair or a square, the radical gets to cancel out with the square. So this is all of a sudden, if it helps, I could technically do an in-between step. My in-between step would be root 6 times 6. But this is written weird. See, it's confusing, like were you supposed to keep writing it? If someone's been freed, we always write them in front, just because that way our brain can see it a little bit easier. So we technically let this guy go free because he was a square. So he's free of the radical, and then I write him in front to be clear, and now I can see, oh, they're like terms, I can clear it. Does that make sense? Now guys, I think we've all had at least enough time to try it, whether or not we totally got it. Can you tell me what this way is? This is one solution. This is one way to the solution. How did I start? I started by distributing. And when I distributed, I got a big old fat 216, which I had to go ahead and divide. You could have divided by 2 or by 3. The group up here said divide by 6, and it totally worked. But some of you didn't go that route, and that is totally okay. Maybe you got to the final answer, and maybe you didn't. The final answer is down here, 3 root 6. But let's just check your work real quick. The other way says, break this guy down now. And 72, I heard some people say that it was 2 and 36. But I heard other people say that it was 9 and 8. Were they wrong by saying 9 and 8? No. They're right. 9 and 8 isn't bad. And if it helps, you can rewrite the rest of the problem. But we can't combine unless they're like terms, and we're trying not to distribute. So then, okay, we could break down the 9. Now, some of you know that square root of 9 is 3. You can look up here. Maybe you know that you can go straight to 3. That will save you some time. But if you don't, you could break down 9 to be 3 and 3, which I like making one big radical because that's about to be a 3 squared, which I love squares because the radical lets them go free. Squares with radicals are free of the radical. Now, hold on, I still had my 8. He can be 2 and 4, right? Now, I'm going to separate because that's only 1, 2. That doesn't help me. But the 4, some of you have memorized that 4 goes down to be 2, the square root of 4. But if not, it's okay. You might have kept going. And if you kept going, haha, there's another square. There's another pair. So it kind of depends on your brain as to what it sees and how quickly it can make some of these jumps. Because some of you would say, you're a 3 on the outside, and I don't know, you're a 2 on the outside. But others of you, it might take a little more time to be able to see, okay, there's a 3 that's been squared, there's a 2 that's just by himself, and then there's a 2 that's been squared. And that's all from the 72. With, I know we have all the rest of the stuff still there that we haven't dealt with. But remember, you can get to any ones that are perfect squares, whether you see it this way or whether you see it this way. They get to go free. Now, the 9 doesn't get to go free. But who he's the perfect square of does. So this 3 is going to come out in front. This 2 is going to come out in front. Anyone who's free can come in front, and anyone who's not is just going to stay underneath that radical. So maybe some of you saw there's a 3 and then there's a 2. Or maybe you did 2 and 36 and you realize the 2 is stuck and 36 can become 6 times 6, which is a perfect square. So the 6 becomes free. But either way, PEMDAS would tell me I have a 6 root 2 minus a 3 root 2. What can I do since they are like terms? Yep. And what happens when I subtract? I heard it. You get a 3 root 2. Now wait a minute. What's in front of this root 3? Who's the number in front?
1.
Is a 1. And so what happens when I multiply? I get a root 6, and then what's on the outside? Good. Because do both ways work. Both ways work. Just they're a little bit different in their approach and in how they go about the problem. Yeah. Good.
But I ended up with, when I did 2 and 16, I divided it by 6.
Okay.
And then I did it 3 times, then I got 3 squared.
Oh, I see. So like you made one big root here, right? You had 6, 6, 6.
Yeah, well, I just did the box.
6 times 6 times 6. Yeah, no, that's okay. So then with your box, you could have had because she was just dividing, and when she divided, she realized, hey, this 6 guy goes in a lot.
Yeah, so I did it like that, and then I got 3 squared 6, then I got the same answer, but instead of the 6, 6 minus 3 squared 6, I
Is
just
that
got,
right? That's on. All right, keep going.
I just got 3 squared 6 minus 3 squared 6.
Oh, you got a 3 instead of a 6. Guys, someone's phone is on. Please turn the sound off, number 1, and number 2. Please make sure you're not on Snapchat. But I see this kid, but I think you got a little confused as to what this was. So remember, we're only looking for perfect squares. So then you would have wanted to group it and say, hey, I have 2 and then I have an extra 1. It's going to be easier in your brain that way. So instead of writing all 3, I didn't want 3. I wanted 2 to be able to go free. But I can't just ignore the extra 1. So I can write all 3, or if it's a little bit easier, maybe it's even easier in your brain not to use the exponents and instead do it like this, like the way that it's actually shown. And then you can say, hey, I have 2 of them, so I can do that 6 squared, but then I have an extra 1 over here. And so then the squared and the square root, there's a 6 that's on the outside because of the 6 that's squared.
So then you end up with the 2 6s?
With the 6 root 6, yeah, because there's 1 that needs to stay, and then there's a squared, so that 1 gets to go through.
But they're both inside the square, so how would you, why do you
Well, this
not
one-
combine them?
This one was under the square, but remember the square lets them go free. So because there was 2 of them, I could rewrite that guy to be a squared. And remember, I can split up radicals. Like as I'm doing my, see, I'm splitting up the radicals to go to everybody. But I like grouping the 2's together because that's really clear as to when I'm allowed to cancel out the radical. That kind of makes sense.
Yeah, so then from the 6 squared 6, what would you?
You're right here. You got this to be this, and then you still have the minus 3 root 6, but you need to now combine like terms.
Okay, so then you keep the 6 the same.
Because it's like if I had a 6x minus 3x, I'm just saying how many of them? Oh, I have 3 left over. It's a label more than a number, if that makes sense.
Okay, so since they're both the same, it's just 6.
Yeah, 6 of those root 6's minus 3 of those root 6's means there's a total of 3 of those root 6's. Sure.
Yeah, that last part again.
Here to here?
Oh, the red one.
Oh, sheet. This one?
Yeah.
Oh, this one was starting back at the very beginning and taking the 72 before multiplying and breaking it down. I'm not sure what step you wanted me to explain, but from the very beginning.
I mean, like the last part we did the last one.
Oh, right here?
Yeah.
Okay. When we multiply radicals together, whatever is underneath the square roots combines under the radical when you're multiplying, and whatever is outside combines, because technically multiplication is commutative, so I could actually rearrange this.
Basically, multiply that one.
Yeah, I'm basically rearranging it to get the radical guys together. And 1 times 3 is, well, actually I can go one step better. I'm using a lot of properties to rearrange and then to put together. So these end up together and those end up together. I'm just doing it in a shortcut way. Now guys, listen. Okay, tomorrow we have a quiz on what section? 9.1, A and B and C, right? I didn't get to walk around and check your worksheets just because you guys had a lot of questions, but I don't mind a lot of questions because this is kind of one of, like, I don't know, the biggest problems of the section, because there was breaking down, there was multiplying, and there was adding and subtracting. The one thing there wasn't that you guys might need to study tonight on your own to review is rationalize. We didn't review rationalizing today because it wasn't a part of this problem because there were no fractions. But the homework quiz is tomorrow, and have worksheets A and B and C ready, and homeworks A, B, and C ready. Yeah? Okay. Thanks. You guys get out of here. Join me.